Hi, we're moving along in our chapter 9. This is our section 3 in our unit 6, and we're talking about significance tests for a difference in population proportions. So when it says proportions, we're talking about more than one. So we'll be working with two of them. So our learning targets for this section is to state the appropriate hypothesis for performing a test about a difference between two proportions, population proportions, check the conditions just like we did before, calculate the standardized test statistic and our p-value, but now it's going to be for the difference between two population proportions and perform a two-sample z-test for a difference in proportions. So in a test comparing two proportions, the null hypothesis has a general form. It's usually called the null hypothesis is P1 minus our P2 is equal to our hypothesized value. But in AP statistics, we'll probably usually focus when the difference is equal to 0. So a lot of times my brain usually works and I think, okay, when I'm reading the problem, they usually say that they're equal to each other. So our null would be P1 is equal to P2. And then I just think back to, okay, it does have to be a difference is equal to 0. So I do some math, move the P2 over and equal it to 0. And usually this is the one that you'll see me write down. The difference between them, that will equal to 0 there. The alternative hypothesis will be one of the three forms. It could be P1 is greater than P2, P1 is less than P2, which these are one-sided, or P1 does not equal to our P2, which remember, that's our two-sided tail on our normal curve. Now let's practice writing the hypothesis when it's a two-sample population proportion. So in this problem, it says consumers spend billions of dollars each year in the drive-through lanes of U.S. fast food restaurants. Having quick, accurate, and friendly service at a drive-through window translates directly into restaurant revenue. As a result, industry executives, stockholders, and analysts closely follow the ratings of fast food drive-through lanes that appear each year in QSR, a publication that reports on the quick service restaurant industry. A recent QSR study involved researchers asking for a modified made item. So for example, hamburger with no pickles, a side item, and a drink. If any item was not received as ordered, or if the customer received inaccurate change or no napkins or straws, the order was considered inaccurate. So the question is there convincing evidence of a difference in the population proportion of accurate drive-through orders at McDonald's and Wendy's? And then the second part is state the appropriate hypothesis for performing a significance test. Be sure to define the parameters of interest. So here, our null hypothesis is that there is no difference between McDonald's and Wendy's. So because there's no difference, the McDonald's proportion will equal the Wendy's proportion. So I did a little bit of math, and P sub M, and notice that I write it in using the context. So P sub M minus P sub W is equal to 0. Our alternative is that there is a difference, so it doesn't equal to 0. And the parameter, I do need to state what P sub M is. Remember, whenever we have variables that we're inputting, we always have to state what they are. So P sub M is the true proportion, population proportion of accurate drive-through orders at McDonald's. And P sub W is a true proportion, population proportion of accurate drive-through orders at Wendy's. So that we're stating what the hypothesis is for each of them. And then notice again what I had stated before. Technically here that there is no difference and that there is a difference. And for this one, I usually like to set it equal to 0 to make it easier when we draw the normal curve. So assuming that the null hypothesis is true, P sub 1 is equal to P sub 2. The common value of these two parameters is called P. So to estimate P, because we don't have it, we combine or pull the data from the two samples as if they came from one larger sample. So the combined sample proportion, and it should make sense here, P hat combined, that's why we use the C, is the number of successes in both samples combined and the number of individuals in that sample. So we use X sub 1 plus X sub 2. So we're combining the two samples and that sample size as well. We're going to combine them. And that's how we're going to end up with the new pooled value. Now, in other words, P hat combined gives the overall proportion of successes in the combined samples. And that formula is in the reference sheet. So remember when in class, I always ask you to go back to the reference sheet in the first page in the back of it. We're going to look for when they're talking about the difference of two proportions here. Now, when we're checking conditions, we're still going to check the random. The data has to come from two independent random samples or two groups in a randomized example. So make sure that you're talking about both of them here, not just one. We do need to still check the independent, so the 10% condition. If it's without replacement, you got to do both of them. The sample of the first has to be less than 10% of the population of the first, and the second sample has to be less than 10% of the second population. And then the last one is the large count, and this is where some students sometimes find some error. And this is because we are talking about two, we're talking about the difference. So we do need to use the pooled, the combined proportion here. So it's going to be the P hat sub C. And we got to do it for the first sample and our second one as well. And that has to be at least 10. So we do need to do both there. So let's look at this problem. We're still working with the McDonald's and Wendy's drive-through orders, but this is what the sample they're telling us. So they chose 150 drive-through orders, of which 145 were accurate, and that was at McDonald's, and in Wendy's, 139 out of the 163 drive-through orders were accurate there. So is there convincing evidence of a difference in the population proportion of accurate drive-through orders at McDonald's and Wendy's? So here we're going to go ahead and check the conditions for performing the test in order to make sure that they are met. So we're going to go with random first. You do need to do it for both. So independent random samples of 159 drive-through orders from McDonald's and 163 drive-through orders at Wendy's. Then we're going to go ahead and do the 10%. 159 is less than 10% of all drive-through orders at McDonald's, and 163 is less than 10% of all drive-through orders in Wendy's. Now, we do need to check the large count, but remember with the large count, we do need to use the combined proportion or pooled, which is going to come from our sample, the ones that were accurate over our total. So our P hat combined is going to be 145 that were accurate at McDonald's, plus 139 that were accurate in Wendy's. And that's going to be over what we actually surveyed, which was 159 plus 163. So this is the pooled combined proportion that we need to now use for the large count. So when we're working with two, the difference between two, we do need to make sure that we're using the combined. So we're going to check the large count. So remember here, we need to do N sub 1, so our McDonald's. So that would be 159 times our combined pool here, proportion. And then we're going to do it for all of them. And notice that they are all at least 10%, so they are all met here. Now, we're going to go back and think about how do we find our standardized test statistics. So remember, it's our statistic minus our parameter and then our standard deviation of statistic, Okay, that's what we were doing. So our statistic here, so remember we're talking about the difference. So it's going to be p hat sub 1 minus p hat sub 2 minus our parameter. But remember with our parameter, we always went back to our null hypothesis. And in our null hypothesis, it was 0. And that's how we're going to be using that. Now you do have to be careful. Usually it is 0, but not always. But for most cases, it will be. And then remember here at the bottom, we're using the standard error, which is going to be using the combined proportion. So we do need to make sure to note that. And this formula, well, the pieces of it are found on the reference sheet, but this general one is in the front of it. So remember the statistic, it is the difference, and then minus our parameter, which comes from the null, and then our standard error, making sure that we use that the proportion, the combined proportion there, the pooled one. And then to find the p-value by calculating the probability of getting z-statistic, this large or larger in the direction specified by the alternate hypothesis in the standard deviation. So it could be one-sided, either to the left or to the right, or two-sided. So you do need to make sure to go back to the alternative to figure out which one you're doing. So remember the formula sheet does give it to you. It gives you the generic one here, which is our template, and then you can get the pieces of it when you go to the section where it talks about sampling proportions. Let's look at continuing with that same type of problem here. Here it says, explain why the sample result gives some evidence for the alternate hypothesis. Well, remember that what we observed, which is the p hat of McDonald's minus the p hat of Wendy's, was 145 out of 159 minus 139 over 163. When we subtract that, that's 0.059. So notice, which gives us some evidence that the alternative, which remember the alternative does not equal to 0, because notice 0.059 is not equal to 0. So there is some evidence in favor of that alternative hypothesis. Now, is there convincing evidence of a difference in the population proportion of accurate drive-through orders in McDonald's and Wendy's? So now we're still going to calculate the standardized test statistic and find our p-value. So remember, we need to find our combined proportion there. So we're going to do the 145 plus 139, and then we're going to divide it by the 159 plus 163, and we get 0.882. Now using that, we can get our test statistic, which remember it's our statistic minus our parameter over our standard error. And then again, noticing we're using that proportion combined there, the combined proportion. So our z is 1.641. Once we have that, our z, now we can find out what our p-value is. So we do need to go back to our alternative and see if this is going to be one-sided or two-sided. So here it's going to be two-sided because they're saying it's not equal to 0. So we can use the calculator or we can use our table A. But remember, you can use the normal CDF and just find one side and then double it, which we get 0.108, 1008, which that will be our p-value. Or we can use our table A, find the left one, which would be the negative 1.641, and then whatever we get there, we can double that value. So looking at this one, now that the conditions are met, what conclusion would you make using the alpha level of 0.05? So remember we stated this is a two-sided, so here's our normal curve. Okay, here's negative 0.059, which is the p hat sub m minus p hat sub w. Okay, it is two-sided there. because the p-value that we just found was 0.1008, which is greater than the alpha. Remember, we have different parts. So our first part, we failed to reject the null, okay? And we have that there's no convincing evidence of a difference in the population proportion of accurate drive-through orders at McDonald's and Wendy's. Now, our AP statistics tip here is the formula for the two-sample z-test for the null, P1 minus P2 is equal to 0, often leads to calculation errors by students. As a result, I recommend that you use your calculator, which I'll show you how to do it, just to check to make sure that you're going in the right direction. And don't forget to do the state plan do conclude, and I do want you to show all the steps. And again, this is called, the inference method that we're doing is called a two-sample z-test for the difference in proportions. So it's very important that you state if there is a difference here. You can't just say two-sample z-test. You got to say two-sample z-test for a difference in proportion. And that's a significance test for the null hypothesis that the difference in proportions of success for two populations or two treatments is equal to 0. Now let's look at this problem and let's put it all together. The Helsinki Heart Study recruited middle-aged men with high cholesterol levels but no history of other serious medical problems to investigate whether a cholesterol-reducing drug could lower the risk of heart attacks. The volunteer subjects were assigned at random to one of two treatments. 2,051 men took the drug gemfibrozil to reduce their cholesterol levels. A control group of 2,030 men took a placebo. During the next 5 years, 56 men in the gemfibrozil group and 84 men in the placebo group had heart attacks. Do the results of this study give convincing evidence at the alpha equaling 0.01 significance level that gemfibrozil is effective in preventing heart attacks? So here we're going to have to do the 4-step process. So the first process is to state, we got to state our null hypothesis. So our null hypothesis, if you notice the subscripts, they are contextual. So our null is P sub G minus P sub L is equal to 0. And our alternative is that their difference is less than 0. And then we're going to now define our parameters. So P sub G is equal to the true heart attack rate for middle-aged men like the ones in the study who take gemfibrozil, and P sub L is a true heart attack rate for middle-aged men like the ones in the study who take a placebo at the alpha level is 0.01. And again, notice there is no difference. And then we can, if we're depending on where we're writing it, you got to make sure to put the correct order. So here I put the first one, which is the drug minus the placebo, and that has to be less than 0. But if you put the placebo minus the drug, then that would have to be greater. So you do need to make sure that the order you stick through it throughout the problem. Now we're going to go ahead and we did the state, now we're going to do the plan portion. In our plan, we do need to state what inference method we are using. So we are talking about two samples. This is a z-test for a difference in proportions. So we do need to state the inference method. Now we got to check our conditions. So the first condition is random. So the volunteer subjects were randomly assigned to gemfibrozil or the placebo. Very important that you talk about plural here. We're talking about the subjects. If you don't write that, that is completely incorrect. So the wording does matter here. Then notice that the 10% we don't need to check because the subjects in the experiment were not sampled without replacement from one larger population. So we don't have to write the 10% condition. So then we're going to move on to the large count. Because this is a difference in proportion, remember we do need to use the proportion, the combined proportion there. So that's the first thing we're going to need to find for the large count. So our p hat combined would be 0.0343. And then we're going to go ahead and check the first part, and notice that all of them here are all greater than or equal to 10. Now we're going to move on to our third step, which is the do portion. And in the do portion, we do need to write our statistic, which is our p hat sub g is 56 out of 2051, and our p hat of our placebo is 84 out of 2030. And remember, to find our standardized test statistic, we need to go ahead and find our statistic, which is the difference between the two. When we find the difference, we get negative 0.0141 minus our parameter. And remember, we go back to our null hypothesis, which was equal to 0, over our standard error. And remember, we're using the p hat combined information there. And we end up with our z to be negative 2.475. And remember, now we're going to go back to our alternative hypothesis. And because we're standardizing the normal curve, we do need to make sure that we write our notation. N, our mean is 0, our standard deviation is 1, since we are standardizing it. Here's negative 2.475. And we go back to the alternative, which we said that their difference was less than 0. So we're going to be shading to the left here. Now, from there, since we shaded to the left, we do need to find our p-value, okay, this probability here, that area. So what we're going to do is we're either going to use our calculator and do normal CDF and do our lower, our upper, our mean, our standard deviation, and find our probability, or we can use table A and find that probability as well. Now our last step is to conclude. So notice that we found the p-value to be 0.00675. So because our p-value of 0.0068 is less than our alpha, which is 0.01, we reject the null, and there is convincing evidence of a lower heart attack rate for the middle-aged men like these who take gemfibrozil than for those who only take the placebo. So here we're going to go ahead and interpret the p-value just to make sure that we refresh on how to interpret that. So interpreting the p-value, remember, we're going to state we are going to assume that the null is true. So assuming that gemfibrozil is equally effective at preventing heart attacks as a placebo, there is 0.068 probability of getting a difference, and you do need to state the order on how it appears in heart attack rates for the two groups of negative 0.0141 or less purely by chance. So remember, this number here comes from the subtraction of p hat sub g and p hat of the placebo. And that's how we got that value. And that would be the exact difference. And that is the third section of our chapter 9. We have one more, and these were the learning targets for this section.